Yeah. All right, here's a little project from yesterday. Done a couple others of these. This is a sump off of a Lycoming, and what happens is these tubes in the sump, they come loose, and also you can see the beading here and here, and there's another one up inside. Just goes in and swedges out into the case, and so for starters, I have to locate where that's at. And easiest way I found to do that was set up in the mill, and then I just set this, mount this in a Noga, knowing that I'm, running parallel to my axis. I just use my coaxial indicator, locate this edge, and then I can read my deviation every time I drop into a low spot, and using my digital readout, I can identify from edge to where that final groove is up inside the sump there. So I use that to identify where the tool needs to shoulder and swedge. So from there, I come over, hold on, reposition, and what I've done a better, different style, I guess I should say, in the past. Takes significantly longer, but this works fine enough. So this just goes in, obviously inside. I've got 3 holes around the diameter. Once this will get a final assembly later on, because once it's all together and locked into place, it won't come back apart. It can, but not anytime soon. So the bearings will go into the hole. Originally I reamed those for about a thou clearance, but I found that any amount of trash or debris, they hung up. So I had to open those up just a couple more thou just to get them to float in there. And when those go in, I just simply stake them on the side just so that they don't come out. And then the nut, when the nut goes on, so it acts as a stop. So it'll come flush on the end. So there's a shoulder inside, and when it shoulders out on the inside, it's at its largest, most diameter, which will be what swedges the tube. And then when the nut shoulders out, that's at its minormost diameter, so then the bearing is flush with the OD of the tube. And then this just simply goes, if I can put that caught again, that just goes up inside the tube like so. And then that'll back out to extrude the bearings. Then you just simply rotate it. All it does is just forces the bearing out into the case. So yeah, kind of a simple little project. A little time consuming. I had some issues with it, my fault entirely. But so to start with, I wasn't able to get it to extrude completely. So when I would screw the internal into the body, it wasn't coming down far enough to fully engage the bearing. And I thought it was because of my shoulder. I don't know if that's even going to get caught. There's a shoulder in there. Didn't know if it was, I thought my shoulder needed to get pushed in, so I loaded it back in the lathe, pushed that face down a little bit, thought everything was good, so I went and stuck it back together, and when I threaded it in, I still landed in the same spot. Well, the issue was I had more threads inside than I thought I did when I counterbored. I thought I counterbored farther than I did, and so anyway, so then I had to pick up on this thread, and I ran it back a ways, and then I just relieved that shoulder some. So yeah, that just goes in and shoulders out for the maximum amount of penetration into the case, into the sump, and then when it actually doesn't come up that far, then there's the miner, and they're just a 3/16 ball from McMaster-Carr. Yeah, so it's a swedging tool. Nothing exciting, and of course I didn't show any of the machining side of it. To everybody that takes the time to set up cameras and do all that, hats off to you. To everybody that does, lots and lots of editing, greatly appreciate it. I love watching videos. But what little bit I've done It's time consuming. The camera definitely gets in the way of stumbling around the lathe, and anyway, I haven't found a convenient way to do it, and you know, it's fun to share, but in the end I am trying to build parts. So in time, maybe I'll do something different later, but for now, so that's a share of one little project. Thanks for checking it out.